Okay, the infamous water bucket question. You could find a bucket of water at home or just any sort of water container with a handle. If you spin it in a vertical circle fast enough, the water will stay stuck in the bucket or whatever you're spinning, and water won't fall out. I've got a bucket in class. In class, we'll actually spin a bucket around so you can see it. What I was trying to say in the last question, the roller coaster at the top of the hill, is what happens at the top of a vertical circle kind of depends on where the object is. Is the danger that it's too slow and could fall down, or is the danger that it's too fast and could fly and become a projectile? In this question, the danger is that if you go too slow, the water might fall out of the bucket. Gravity might be too big. I'm going to try and draw this. So here's our circle. When we do it in class, my bucket usually is red. So there's the bucket. We've got some water in the bottom. I don't have a blue pen, so we got purple water today. Water down here. Some strings attached, and then we're spinning this thing in a circle. It's weird to think of drawing a free body diagram for water, but if we did, the only force acting on the water is gravity. And if it's going really fast, a normal force. As we slow it down and go slower and slower and slower, the normal force eventually drops off to zero. That's the slowest we can spin it. If we go any slower, gravity's too big and the bucket and the water are going to fall into the middle of the circle. I could spin it faster. As long as the string doesn't break at the bottom, I could spin it faster. The normal force at the top would be down to help gravity. But if I spin too slow, then the danger is it might fall into the middle when gravity's just at that point where gravity's just enough to make it go in a circle. If I go any slower, it'll fall into the middle. Gravity's too big for the radius and speed that I'm going at. So when I set up F net equals ma, it kind of looks like the last one we were on the roller coaster. The normal force to drop to zero. So I'm going to get Fg equals mv squared over r, or mg equals mv squared over r. So the condition looks the same. It's v squared equals rg. Just this time, this is the slowest we can spin it. If we go any slower, the water's going to fall into the middle. And for this one, the r that I made up was 1.5 meters. So multiply square root, I'm getting 3.8. So if you're brave, if you can find materials at home, take some sort of bucket, spin it in a vertical circle. As long as you're not going too slow, the water will just stick on the bottom and it'll follow around the bucket as you go in your vertical circle. The danger would be if you go too slow, gravity's too strong, it wants to pull it into a smaller radius, or basically